Let's continue with section 2. What is section 2? Section 2, it talks about properties that depend on the concentration of solid particles. We'll talk about colligative properties. What are colligative properties? Properties that depend on concentration of solid particles. So they are the properties only depending on concentration, not their identity. So only concentration can affect colligative properties, not what type of solid it is. For example, between glucose and sucrose, we don't care about they are different. We care about their concentration. What is their concentration? And in this section, you know, concentration can be divided, or we can measure concentration in two ways: molarity or molality. But in this section, we will use molality. If you go back to the notes of chapter 1, section 3, we said at which times do we use molality? When we talk about vapor pressure and changing temperature. And this section contains both of them, vapor pressure and changing temperature. That's why we have to use molality. Where molality. The colligative properties are 4 properties: vapor pressure loading, freezing point depression, boiling point elevation, and osmotic pressure. Now, first, let's start with vapor pressure loading. And before we start with vapor pressure, in the book says all the solutes that are used here are non-volatile. What is non-volatile? So it's exactly opposite of volatile. Non-volatile doesn't want to become gas, has a little tendency to become gas. But volatile is something that can easily become gas. For example, acetone. All of you have seen acetone, or like gasoline. If you open the bottle, you can see after a while all of the acetone has gone. Why? Because it's volatile. But in this section, we talk about non-volatile, which mostly are solids, which they don't want to become gas easily. All right? Then what is vapor pressure? What is vapor pressure? It's the pressure caused by the molecules in gas phase that are in equilibrium with the liquid phase. For example, let's say we have a container like this. This is the cap of the container, and the cap is closed. This container contains water. Just water, nothing else. Just water. This water, at a certain temperature, it will evaporate. But then, when the amount of like gas particles, in this part we have gas, which is vapor, contains a lot of, when it reaches a certain amount of vapor, when the pressure is so high, so it has a vapor, it has a pressure. Gas has pressure, you know, gas has pressure. So after a while, when the pressure reaches a certain amount, it doesn't let any more water to evaporate. Then it starts to condensate again. It starts condensation again. At this point, there is a change between these two. There is a process, there is an equilibrium between liquid, all right, between liquid and gas. And what is that? What is the process between them? From liquid to gas, it is evaporation. But from gas to liquid, condensation. These two processes, evaporation and condensation, will reach equilibrium. They will be equal to each other. All right, they'll be equal to each other. Then, this pressure present here, what do we call this pressure? We call it vapor pressure. We call it vapor pressure. So the amount of pressure that is like produced by evaporation of a liquid and produces some amount of gas, and it applies some pressure, we call it vapor pressure. Solventek. كاتك solventek. evaporate كات لتمبشري ديالي كراوة لتمبشري evaporate كات غازكي لحد كا pressure دو سكات يتشيليت دو بار كوندنس بيتو اگربون منا molecule كي او بي evaporate كان لهمان كاتم او molecule. If one molecule of water wants to become gas, the same molecule or another molecule of water must become liquid. So it will reach a precipitation. Sorry, a condensation or be at equilibrium. Kato kata chile, agata. All right. Now, that was vapor pressure, and it depends on how much temperature, at a certain temperature, sorry, it will reach a point where it forms a some amount of pressure here at this point, because it contains gas. Now, if we talk about that concentration can affect this vapor pressure, this property. How? If we increase the concentration, will the pressure increase or decrease? Here's the point. It says the vapor pressure of a solvent when it contains a non-volatile solute, so when it becomes a solution, is lower than what? Vapor pressure of the solvent alone, pure solvent, at the same temperature. Look at this figure. This figure explains it very well. And figure is زوج عن شرحها. This is pure solvent. All right. The water has evaporated. This is closed. This contains more gas, so it will have a higher vapor pressure. Why? Because if you look at them, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 12 and 6, 18, let's say it contains, for that point, it contains 18 particles of gas. So more gas means more pressure. So it will apply a higher pressure. So that pressure what? Vapor pressure. But look at here. There are some solutes here. Solute here. These solutes make this solution. So this one is solution, not solvent. It's the solvent with solute. This solution cannot make the same amount of gas as the solvent. For example, this was 18, I think. 2, 4, 6, 8, 11. So less gas particles. Less gas. And less gas means lower vapor pressure. So I think gazi kam tervet, ya pressure shi kam tira. Wanya, gazi kam tervet, pressure shi kam tira. Boya, ema lera jawazi la beni udwana akin. If something is pure solvent, what would happen if we put some solute? We will say the vapor pressure will decrease. See? From the solvent which has more pressure. Why? Why the vapor pressure decreases? That's what it means lowering. The lowering is the change. Is the change. It is lowering. How is it lowering? By increasing concentration. Why? Because as the number of solid particles increases in a given volume of solution, free solvent water molecules decrease. كانت تصير وياه لبر away. Particularly solute كان زورا بن Chiliet solvent free minute. So there will not be any more free solvent. How? You remember from chapter 1, when we dissolve something, the solvent particles surround the solute. And what is the solute? It's a non-volatile solute. It will grab the water, it will grab the solvent, and it doesn't let the solvent to evaporate easily. Chiakat solvent agreed? Reganaya solvent ba'asani evaporate kat. Reganaya solvent ba'asani evaporate kat. All right? That's why vapor, if it doesn't evaporate more, there will be less gas, the vapor pressure will be lower. Kawata agarbetu. Pressure, babla evaporation kam tirka? Kam tirish gas manabet, kam tirish pressure manabet. Basha. Now, again, if we increase concentration, see, if we increase the concentration, the solute will grab the solvent. It will not let the solvent to evaporate easily. And the barrier get solute concentration زيادة. Regri لو أكاد solvent evaporate. If it doesn't let the solvent to evaporate more, then we will have less gas, then less vapor pressure. Then what is the relation between them? So what is the relation between them? As we said, the vapor pressure is decreasing when we increase concentration. So they are inversely. But the change, lowering is the change. The more the concentration, the more the vapor pressure will be lowered. So the change will be higher. So it's directly. Let me draw you a graph. Let me show you. How is this possible? Like this. Let's say this side is concentration. This side is vapor pressure. This side is vapor pressure. Y-axis is vapor pressure, x-axis is concentration. Let's say both of them here are 0. All right. At zero concentration, let's say here, if vapor pressure is, let's say it's 0.3 atm. Let's say it's 0.3. As concentration is increasing, let's say it becomes something, as concentration is increasing, vapor pressure at this concentration is lowered. The vapor pressure would be at a lower amount. If concentration is increased even more, vapor pressure is lowered even more. So, as a number, let's say this number is 0.2, this number is 0.1. So the vapor pressure is decreasing. So concentration and vapor pressure are inversely proportional. As concentration has increased, vapor pressure has decreased. Concentration is increasing, vapor pressure is decreasing. But what about the change? Why does the change increase with concentration? Everyone, this one is the change. This part, that's the delta. This part is also a change. So as the concentration is increasing, look at the change. The change from 0.3 to 0.2 by a certain amount of concentration is 0.1 change, but after a while it becomes 0.2. And when the concentration is increased, the change becomes 0.2 change. So as concentration is increasing, always with the change is directly proportional with the change. Always. فهذا كلنا. بالرقم في الرقم كم؟ vapor pressure هذا عوضه. بونمنا. كواتا كconcentration من ذاكر vapor pressure دابازي inversely. Vapor pressure بتاعتنا alone vapor pressure is inversely. بتاعتنا inversely. بس اگر بحثش چنجا كيدين كير كنا حتى يتخواروا حتى vapor pressure بيتخواروا چی زیاده چنجەکەی زیادە دا گۆڕانکاریێکی زیابێت یعنی زۆرترە گۆڕێ ڕێگەی خۆمان چییە how can we say the more concentration the more vapor pressure lowering the higher the concentration the higher vapor pressure lowering that's why they are better the higher concentration the higher vapor pressure lowering. So at the chin, so that's why they are directly proportional. But vapor pressure is inversely proportional because it's a number and it's decreasing. But here, yes, it is decreasing, but we have added lowering. Lowering means the change. So the change is increasing. It is changing more and more. As you increase concentration, from where? From the initial to the final, it's changing more and more. That's why they are inversely proportional. Inversely proportional. Is there anyone who has a question? هذه أنا جشت به.
والله سؤال من ميت أنا جشت مع زلنا بزيادة وكمان بريشر كان.
جابت. كرب. vapor pressure بتاعك تاني شيء لحد. ده أنا بزيوه. بحشة. حتى أكو concentration ما زي بابلين زيادة كريمة vapor pressure ده بزيوه. حتى أكو concentration زيادة كريمة vapor pressure زيادة ده أنا بزيه. بكل دقيقة خمان. concentration زورتر به زورتر ده بزيه. اگر دو کلمه چی مکانه هر دو کلمه زورتر بکارن فهات لکاتک بو لبریک زورتری دو من کلام زورتر دا بازه بس چی کم گوران کاری که یکم زورتر اگوره زورتر دا بازه چینج کی زورتر بت فهات لورینگ لبی مدام بس یو کا کچنه گوره زور گوران کما گوره الان زور گوره بو دوی الگا کنسنتریشن یا بالا مگر بس یو پرشر به تختنیاب کینو کو رقمک اینورسلی چون که دابازینه موضوع
يعني ما صار كونتاكت بيني بريشر وكونستريشن دايركتلي يعني بعكس يكون
بله بعكس يكون بلا مگر بلين شن ازور غورن كما غورت الين دايركتلي تيجشتي اي غورن كاركي دايركتلي
ما وصلتين بلين كونسنتريشن نحن كاتك هاد كما بيدو
خويك سيرجا كرم concentration اما اوي كبدس اما concentration اما we can only change concentration. So when we change concentration, what will happen to vapor pressure? عوامل بيدك So concentration زيادة vapor pressure ضعفة. يعني إما دسكاري concentration لكن كزيادة يعني كم يمكن. بلا ما بيز أو بزانك vapor pressure ضعفة زي كم. باش مرة. باش. Now we said we use non-volatile. We also use mostly non-electrolytes also. Non-electrolytes solids we are just most of the time we're going to use. So non-electrolyte solutions of the same molality will have the same concentration of particles. So they have the same amount of particles. That's why they have the same effect. What did we say on top? We don't care about the identity. We care about the concentration. So if two things have the same concentration, we'll say they will affect colligative properties equally. فهذا قربته دوشة concentration يعني هو يكبه باقيكش affect against colligative properties. For example, this is an example. And 1 molar aqueous solution of glucose. This is 1 molar glucose. And 1 molar of sucrose, another substance, but they have the same concentration. عارفين concentration هنا. Both are non-electrolytes. هذول كان non-electrolytes. ما زوجي هاد كان electrolyte. أجنبي ما دي جواسة. And they lower. So both of them, the 1 molar of sucrose and the 1 molar of glucose, both of them lower vapor pressure of water by the same value, which is 5.5 times 10 to the power negative 4. Say لكن هذول كان بقيك effect يعني كله تسر vapor pressure. بقيك دام بزانوا. كواتل يرمى شيء ما بوصل منه. دير خواره والله. شيء سلمانوا. Why do they lower vapor pressure equally? Because vapor pressure lowering, which is that property, depends on what? Depends on the concentration of a non-electrolyte solute and it's independent of the solute identity. It depends on the concentration. Since both of the concentrations are equal, then they would have the same effect on the vapor pressure lowering. Identity is not important. باش شكرنا. فهذا identity مهم نية. Concentration مهمة. قاعدة قال بكم مراجعة كما بكين ولنشيا. If we increase concentration, the vapor pressure will decrease. It cannot evaporate more. Why? Because fewer water molecules or fewer solvent molecules will be present evaporate. Because they have surrounded the solute. Solute تيكي solute كان رجلي ليك نايله باستراحتي خوي evaporation كان ناله باستراحتي evaporation كان أو كاتا evaporation كم تركاتو evaporation كم ترك بس زار بحشا مثلا يا see evaporation has decreased on the right side. That's why less gas is present inside the container, inside the gas space. So less pressure is also present. What is the second property? The second property is freezing point depression. The depression here is the change, which means decreasing. So means lowering, like something like that. Decreasing. Now, a solution with non-electrolyzed solute will have a lower freezing point. Again, if we have a solvent and then put some solute in it, the freezing point will decrease. For example, water freezes at 0 Celsius. Water freezes at 0 Celsius. If we increase the concentration, the water will freeze at a lower temperature. For example, it might freeze at -1 or -2 or even -3, depending on the concentration. For example, the change for water is given here. It says freezing point of 1 mole of solution of any non-electrolyte solute in water. It means that if we have, or if we increase concentration, of water by 1 molar, what is going to happen for freezing point? The freezing point will be 1.86 Celsius lower than the freezing point of the water itself. It means that water freezes at 0 Celsius. So pure H2O freezes at 0 Celsius. But 1 molar H2O with solute, it will freeze at lower than 1.86. So the change is 1.86 Celsius lower. So it will freeze at -1.86 Celsius. أو للصفر بس بون هنا. شتيش معناه للجمالتها بس بو أو ببزاني كذا صفر بس يعني. أجر بيتو أمر خمس بس بو أو راسي يكون الشاشة. كاتا أجر بيتو concentration أو بقورن. شكليتي أكن مادة كتيرتي أكن. If you put some sugar or any solid into this water by 1 molar, then the water will freeze not at 0 Celsius. It will freeze at -1.86. So it will freeze at a lower temperature. So we have to decrease the temperature. We have to put it in a colder place so that the water can freeze. All right. What do we call this change for 1 molar? For 1 molar. So molar here means 1 molar per molar. Per molar. So molar freezing point constant, we call it Kf. What is the freezing point? The pressure of 1 molar solution of non-volatile electrolyte. For example, for water, You have to memorize this. For water, the change is minus, you have to memorize this, minus 1.86. The minus means it's decreasing. It's decreasing from 0 to below 0. 1.86 is the change per 1 molar. Per 1 molar. Then what about for 2 molar? We have to find the total change. This is total change in freezing point. The total change, we call it freezing point depression. So if this is for 1 molar, what is the total for 2 molar? Multiplied by 2. 3 molar multiplied by 3. طلعتها. بالتالي بو 1 molar چنكا. بو 2 molar چنكا وين كرتي. بو 3 molar كرتي سيكي. اي بو 0.5 كرتي 0.5 چيكي. رولا كتشي ليو كاتا. حوالي الرولا. Delta TF is equal to KF times molality. KF is for 1 molar, and molal is that is the molar given, for example. If it's 0.5, you multiply by 0.5. And we get the total. The total change.
مامسا KF كبو تشيبو
KF كبو يج molala. همو ماديك بو يج molal الزانين. يعني the KF is a constant number. For every solvent, we know that constant number. We know is that for every solvent, when 1 molar concentration changes, how many Celsius it will decrease. For example, for water, we know it's 1.86 minus 1.86. Basha, as I constant. But I total شنو كبت كرتي molar دكي كتير كنقول من أجتو أجريك molar نبو 0.5 هبو 7 هبو كرتي أوز molar. Basha. And as always, everyone, you know that delta TF, in every place that you study delta TF is always final minus initial. What is the final here? Freezing point of the solution, because delta TF is the change. So it will start from initial. For example, the water will start from 0. So it's the solvent. Here, everyone, please write that down. Initial means the solvent. Just write it in another color. Initial means the solvent. Final means when it becomes the solution. After we have put the solution. So we will say delta TF is equal to freezing point of final, which is the solution, minus freezing point of initial, which is the solvent.
Almost a freezing point depression, delta TF.
Delta TF okay.
Okay.
We use these two rules depending on the given. Which rule we are going to use according to the given and the required. Which gradually we are going to see them and solve the questions. What about these two? These two is just like vapor pressure. Just like the vapor pressure. And that is freezing point depression, which is the change. So if everyone look at this, for example, for 2 molar H2O, from here to here, this one becomes minus 3.72. So at first, this is the change. This is also a change. Second, if we increase concentration from 1, then freezing point has decreased. From 0, it has become what? Minus 1.86. So it has decreased. But what has happened to the change? The change has increased. That's why this one is also directly. This one is inversely. Why? Pay attention to this one. I have increased concentration from 0 concentration, 0 molar, pure H2O, to 1 molar, then to 1 molar, then to 2 molar. So it's increasing. But as the concentration is increasing from 0 to 1 to 2, the freezing point is decreasing from 0 to minus 1.0 to minus 3.72. But what is happening to the change? Look at the change. The change has increased. This change is smaller than this change. So as concentration is increasing, the change is also increasing. That's why the change is always directly proportional. The change is always directly proportional, but the freezing point itself is inversely proportional. If we increase concentration, freezing point will decrease. Any questions? لبرش تاكت تازه بالفعل يكتوس سايكرنيه وردكاري بخود دانشي هو بيت يتبكي
عندها بيست ريكورد كي بيتو ديسان دانش
اگر دانش نو زور باشتر بيك جا سايت يكون ريكوردي كارو هر زور استفاده ليك ان
شاء الله
هرشن دوای لحسابك اسانتر تيغن الراستيا شكاتاكو بسيا حل لكن توزا ام موضوع حساب وشتيك كشي حتى بسيا حل لكن جوان درناك
لا صاحب بينه وش توزك السيرة هكذا اني شيخ وينتو بس حسابك او هيك اللي ديارني نعم لكن باشتري بيت
بالتاكيد سبسيا حل لكن ان شاء الله اسانتر بيت جا كورنا you have to know two things, and that is freezing point of water. What is freezing point of water? Is 0. All right, and Kf of water is minus 1.86. Also, delta Tf, we said is freezing point of solution minus freezing point of freezing point is solution minus is solvent. How do you make this? 0 Celsius. So do you have to write this 0? No. So always for water, only for water, everyone, pay attention. Only for water, delta Tf, like this, is equal to freezing point of the solution. All right. Take a rest. When we come back and we solve questions, it will be a lot easier for you. You'll understand how we are solving questions, all right? How do we use the rules? And even the explanation will be easier. Even the explanation will be more easy to understand. هروني بسيارك محل كرك خمت عنا بالزور بأساني تي again. If we solve the questions, let's look at how can you solve these questions? And imagine the things that I have explained before, and we put it inside this calculation. First, let's look at the given part. What is the given part? It says a solution consists of 10.3 grams of net electrolyte glucose dissolved in 250 grams of water. So mass of solute first is given, which is 10.3 grams, and mass of solvent is given, which is 250 grams, and we know that we have to convert mass of solvent into kilograms, so it becomes 225 kilograms. We have molar mass, which is 180 grams per mole. What else we have? It says what is the freezing point depression of the solution? Let's find delta T. So since it says depression, it is delta T. Find delta T. Of course, you have memorized Kf. Kf is minus 1.86 Celsius per mole. Why? Because it's water. If you look at this graph, this table, on the left side, it's all the freezing and Kf, freezing point and the Kf of different substances. You don't have to memorize. You just use it if there is a question in the chapter review or in these questions. You are going to use that table. But in ministry, don't worry, everything will be given. Except for water, it might not be given, you have to memorize. Now, it says find delta here. Let's find delta here. Everyone pay attention. How do you find delta here? So the logic here, we know freezing point of water is 0 Celsius. That's the logic. From this question, you can easily understand everything. Water will freeze at 0 Celsius, but if we add 10.3 grams of a solute of glucose, how much of the freezing point will decrease? How many points it will decrease? How many Celsius it will decrease? So that's what we are trying to find. The delta T is equal to Kf times molality. Delta T is not about Kf karate molality. We know Kf, but we don't know molality. Where can we find molality? We will find molality just like section 3, chapter 1. Just like the one in chapter 1. We said molality, molal equals to mole of solute divided by mole of solvent. Yes, we have mole of solvent, but mole of solute is still missing. We have to go and find mole of solute, just like chapter 1, just like the one in section 3. Now, mole of solute is equal to its mass over its molar mass. What is the mass? 10.3 grams. What is the molar mass? 180 grams. And mole is equal to 0.057. What? Moles. Now that we have found, just like chapter 1, nothing has changed. Now that we have found mole, put it here inside the mole. Now we can find molality, molar, which is 0.057 divided by mass of the solvent is 0.25. It is equal to 0.228 molar. 228 molar. Then, did we find molar? Yes. We found the molar. This is the molar. We put it here. And then equal to Kf. We know Kf minus 1.86 Celsius for every molar. So for 1 molar, it is minus 1.86. Minus 1.86 point will decrease. What about for 0.228 molars? So 0.228 molars times 1.86, it is 0. Minus, because you have a minus 0.424 Celsius, because this is molar. Units are cancelled, Celsius is left. Again, what was the logic here? What happens when we put 10.3 grams of glucose into water? What happens when we put that amount into water? Will it still freeze at 0 Celsius? No. It will freeze. It will freeze at minus 0.420. So 0.424 points below 0. فهتلقى لا تشيبوا فكرتها. او هشتغل للصفر بستيت اگر بيتو 2.3 جرام لاش لم جلوكوز بكين ناو اوكوا دوزي ما نفوا يكم جالمو من دوزيتو دواي مولالتي دواي خصنا ناو دلتا تي فكوا بومان در كدو نخف الصفر ناتو اي تشنكاتو لا ماينس شوار ماينس 0.424 بوينت لا خوار صفر او بس يعني لا ماينس 0.424 اتوتو ان ابا اي بس تبور فريزن بوينتك اي بس باشا فهذا فريزن بوينتك شي اللي هاد فريزن بوينتك تا بسيط الا هو دارم لا فكرك تيجي شويتن شيء هر كاتك تو ماديك كيت ناو سولفنتكوا لو فريزن بوينت خويا يترناي بس لا خوار ترى بس او لسفلانه بس وقت لما نزيك هاي بس لما نزدوها بس لما نسي هاي بس and so on حتى في ذاتي تبكن بون منا او اويك اما اخوينوا طبعا لسفلانه بس بو لبريوت من بيور سولفنت نيا شتيتي يعني ما ديتي نقطه الشكل تريجي ديك هل كم ترى بس لو كخص كيتوا اشتخص كيتوا زوي بستات نخر درنك بس فهذا ايش دقه خص بتوا درنك بستات لتبشري كنزمتها ماشي. So the next question is a lot easier. It's very easy. In a laboratory experiment, freezing point of an aqueous solution of glucose is found to be minus, this is a minus, 0.325 Celsius. 0.325 Celsius. All right. So let's see what is required. It says find molality, molar concentration. Even though the solution, see freezing point of the solution is given, but you know for water it says aqueous. It says aqueous. For water, you know delta TF is equal to freezing point of solution. So freezing point of solution final is equal to minus 0.325. Then delta TF is also equal to minus 0.325 Celsius. We know KF for water. KF is minus 1.86 Celsius per molar. Now it says find molality. Let's see what is the relation between these three. We have this one. Delta TF is equal to KF times molality. We have no KF. We know delta TF. We can just find molality. Molality is equal to delta TF over KF. KF, so delta TF is minus 0.325 Celsius over KF, which is minus 1.86 Celsius per molar, and the result is, let me just calculate it for a second. 5.86. So it's 0.174 molar. All right, that's it. You are done.
مصدر نيجاتيف 1.16 ملكينا
لما ودا بي أو أساوي نيو تو أكيوس كرم.
بابا ويكوتي من مرازي كان لو دي
هذا اللي بدي كم بالله أو كذا من مرز. ما شاء الله. أوش بنوسن. Next question. Question 3, I will send you as an assignment. Please try to solve it by yourselves. I will send you as an assignment. I will remind you that it's an assignment. Try to solve it by yourselves. I will not even give you the answer key because I want to know what would be your answer keys. I want to see your answer keys.
بخوتي بنيرينو يعني
بله
بخوتي بنيرينو كحل ماكر
بله بخوم assignment بتاعنا نرم هل assignment تاعك submit كان من وين يقرمه ماشي كان. Question 4, A is minus 9 again. The answer key is just like question 2. Nothing is changed. It's exactly like question 2. And this one is, I think it is 4.83. Let me just check. I think it's 4.83. Nine divided by, yes, 4.83. All right, there we go. Okay.
باصة مولاليتي ناتواني بيب النيجاتيف واي
مولاتي ناتواني بيب شي؟
نيجاتيف
لا لا molality قد نيجاتيف 100.
بس مش
Sir,
Yeah.
does molality has another symbol? M is a little bit makes me confused because
Actually,
it is
no.
also
Yeah,
used
you
for.
are right. You are right. So, Moaz, this is what you are going to do. For mass of solute, from now always try to do like this. Just normal M, small m, mass of solute, write mass of solute. For solvent, mass of solvent. Try to do it like this for molality. Look at this one. Look at this part here, this extra. See, always try to write it like this for molality. I know sometimes it's confusing to find, but the units, we only have unit of molality. The symbol, yes, I know we have different symbols, but this one has the unit is gram. This one, the unit is kilogram. This one is the unit is still m, molar. That's why, as a unit, be careful. This is what the units are, but as a symbol, it's better to write them like this, okay?
Thanks for your advice, sir.
Yeah, you're welcome. All right, everyone. Let's look at something else. Another question. Question 20. Question 22. This one, please add minus 20 Celsius. All right, change it to minus 20 Celsius. I don't know why the minus is not written, but it is minus 20. All right. How many grams? So what is the logic here? In the previous questions, it says if we put this amount of mass, then how would the solution will be affected? At what point it will freeze? This time, it says how can we keep the water to freeze until minus 20, from freezing until minus 20. So what is trying to say? It tries to say that if delta TF is minus 20 Celsius, شي وتوا وتوتي شون وإلا كان هتاكو minus 20 أو كان يبسته. But how? If you put some antifreeze into water, you know antifreeze, the radiator in cars. If you put some antifreeze, the water will not freeze during winter times when it's very cold. So at minus, how many grams of antifreeze we are going to need until delta TF is minus 20? All right. What else is given? Mass of solvent is given, which is 500 grams, which is equal to, again, whenever you see solvent, please convert it to kilogram, always. Now, we have delta TF, we have mass of solvent. It says find how many grams. So what is how many grams of antifreeze? It is dissolved in water. So it's actually asking for mass of solute. We know KF. KF is still, it's dissolved in water. So KF is minus 1.86 Celsius per mole. Let's find mass of solute in grams. In grams. So whenever it says how many grams, it means find mass of solute here. Now, there's only one rule where we have mass of solute, and it's in this one. Mole, first, mole of solute is equal to mass of solute divided by molar mass. So we have molar mass, but what do we need in order to find mass of solute? We need mole of solute. So mass of solute is equal to mole of solute times molar mass. We don't have mole of solute. Let's go and find mole of solute also. Where do we have mole of solute also in another rule? In which rule do we have? In molality. Molality is equal to mole of solute divided by mass of solvent. Again, we have mass of solvent, but we don't have molality. So mole of solute is equal to molality times mass of solvent. All right, we said we don't have molality. How can we get molality also? Let's see what else is given. We can see delta TF is given, KF is also given. Can we derive from these two things molality? Yes. How? We know delta TF is equal to KF times molality. So molality is equal to delta TF divided by KF. Delta TF is minus 20. KF is minus 1.86 is equal to 10.75 what? Molar. So now we have found molar. چی من دوزیوه؟ molar من دوزیوه. قرنه. Check it out now. Minus divided by 1.86. Yes. كواتا molar من دوزیوه. Now when you have found molar, you can put it here. Then this equals to molality. What is molality? We found out it's 10.75 molar times mass of solvent. It's 0.5. So this one is 5. So this is times 0.5, 5.37. What? Mole. We found mole. Put it here again. Now this one is equal to, what is the mole here? 5.37 times, what is the molar mass? 62 grams per mole. It is equal to 333.33 grams. Again, let me explain what we did. 37 times 62. Like we can just like 333 actually. Just enough. Like this. What happens if I explain it inversely from the other side? We need everyone. We need 333 grams of antifreeze so that we can prevent the water to freeze from freezing until -20. How? 333 grams is 5.37 mole. Then this 5.37 mole of antifreeze will produce 10.75 molar of concentration. That's why it will not freeze until -20. كاتا تشي رويا لره علين حتى كو ماينس بيز نايبست بتشانك بتشان جرام لانتيفريز هذا 3 جرام لانتيفريز تبكين وكاتا حتى كو ماينس بيز نايبست. هنا حلكت. What do we need? Mass of solute. What is mass of solute? All of solute multiplied by molar mass. Multiplied by molar mass here. We have the molar mass, but we need mole of solute. So we went out to find mole of solute. What is mole of solute? Molality times mass of solvent. Molality times mass of solvent. We didn't have molality. So we went to find molality from delta TF and KF. When we found it, we put it here, we put it here. All right? Boş yazın. حل معك. بس هرچا. اگر هینیش بید، دانو کورناتو انا خطوة کا عکس کنه. برای یکم جارتوانی ام بدوزی تو. دوای بیکیت اما دوای بیکیت اما. رو مثلا شیوازی حل کردی تو حزه که شون حل کردی. باشه.